was found that the rate of money flow for a Joe Don Baker action figure. Does anyone know who Joe Don Baker is? He's a horrible, horrible actor. Absolutely horrible actor. If you have the Netflix, you need to watch the Mystery Science Theater version of Final Justice. It's got Joe Don Baker. I was watching it while I was writing this problem, hence the Joe Don Baker action figure. He is like the Vin Diesel of the 70s as far as a horrible, horrible actor. Now you know. Okay. Blah, blah, blah. The rate of growth is 200x for the first 5 years. What is the present value of the income over the 5-year period, assuming the annual interest rate of 7.7% compounded continuously? Well, we don't have to do all that stuff that we did in the previous example because they actually gave us the R value. Okay? So we just set it up. So we're going to have, we need a color for Joe Don Baker. He's a very pasty person, but I don't think white would fit. Orange it is. We're going to integrate from 0 to 5, because it's over the 5-year period, of the function 200x. And then times this guy, e to the negative rx. Well, our r as a decimal is what?
0.077.
There you go. How should we integrate this? That we could bring out the 200. We don't have to. Because what's the main thing we're going to have to use here? Well, a substitution won't work because if this were x squared here, then a substitution would work. But it's not, it's an x. Integration by parts. Integration by parts. The 1 over k won't work because there's an x here. So in other words, when you have a product and some quotients, you want to consider integration by parts. That's what we did in 16.1, I think it was. Okay. So remember, in the process of integration by parts, we pick a u as something that's easy to differentiate. I got it correct this time. We pick an dv as something that's easy to integrate. Remember, the tricks were, if you have an e to an x involved, you pick that as your dv. So we'll have dv is negative 0.077x dx. And then whatever's left over is your u. In this case, it'd be 200x. Just made the cutoff there. So u is something that's easy to differentiate. dv is something that's easy to integrate. If you would, please find the derivative of u and the antiderivative of dv. I'll do the hard one for you. So to do this integration, that's where that k is going to come involved. You're going to have v equals 1 over k e to the kx. I got an extra decimal in there. I'm sorry about that. Oh my gosh! It took out too much. That's good, I guess. That's fine. So remember, the integration by parts, if you have something of the form of u dv, it is uv minus the integral of v du. So we're going to have u times v minus the integral of v. I don't know if I can fit it, guys. Oh gosh. It's a close one. du 200 dx. Oh, barely. Phew. Oh, I forgot to put my bounds in. Oh, it's not going to fit. All right, I'll just do this 0 to 5. And then I'll draw the vertical line there, 0 to 5. All right, let's clean this puppy up. First off, in both terms here, you'll have a 200 over the 0.077. They both happen to be negative. So we can write it as negative 200 over 0.077 from 0 to 5. And the second one, you can do the same fraction, but you can bring it outside in front of the integral. But notice there's already a negative there, right there. So the double negative will now make it a positive. Is that okay? Either that's okay or everyone is in a state of shock right now. Oh, thank you very much. There is an x here. You know, is it okay if I put the x there? Now here's the part you've all been waiting for. We have to integrate this portion here. Notice it's an e to a kx, like we just had already. Okay. Notice we'd be doing a 1 over negative 0.077. That'd be the fraction that's created from this. Yes? Well, that negative plus that positive would make a negative. And if you can picture it, this would be in the denominator, correct? This number again? Where this number is already in the denominator. So in other words, I'm going to erase this. So we talked about that becomes a negative there, right? So when we integrate, we're going to have 1 over k. Well, what I'm saying is these are both in the denominator. So to save space, we can just say that as 0.077 squared. Because you're just multiplying them. So let's clean all this up. And again, don't freak out. I mean, it's in the video, so you'll see that again if you need to. Boop. All right. So we're going to have equals. So I'm just copying down that first term again. Then we're going to say plus 200 over 0.077 squared. And that's going to, you get that thing back again. Where the bounds are 0 to 5. All right. There is a little bit of good news here. That little bit of good news is since our bounds are the same for both parts, we only have to do it once instead of twice. So you're going to put 5 into the entire thing, subtract, put 0 into the other thing, you're going to get an answer. I got 1942.18. I double checked. 1942.18. The main thing is, do you understand the setup? The function times e to the negative rx. Okay. If the function was just 200 and not 200x, we wouldn't have to do integration by parts. We could have brought out the 200, did the 1 over k deal, called it a day. Since there was an x involved, we had to do integration by parts. So this could be an easier problem.
Yeah, it's just with all the sign switching and
Although this one was more exciting, right? Right. It's like learning how to drive in Europe. Yeah. I don't understand. That's why they walk everywhere.